is when the occurrence, or they have to throw in the non-occurrence. So when the occurrence or the non-occurrence, just because you have to think about the complement of it, of one event has no effect so when the occurrence or non-occurrence of one event has no effect.
What would be like a real world example?
Hold on the likelihood, we'll be right there, of the occurrence of the other event. Notice how there's other people taking notes and writing all this down.
Yeah.
So I'm waiting for them to get done writing before I move on to the next thing, which is what you're thinking about.
No, I was just asking if you had one like on the top of your head.
I do.
Oh.
That's going to be the next thing I was going to say.
Like when you scratch your knee and that's what
So let's think about some independent events. If I have a dice, or a die, dice is plural, right? So if I have a dice and I have a quarter, if I roll that dice, will that affect the outcome of the flip of the quarter? No. Those are completely not going to affect each other, so those would be independent events.
unless they hate each other.
True. But it still is going to keep the outcomes, I guess, just as likely. If I had a deck of cards and I withdrew a card and then put it back, do I still have the same outcome or likely probability in that second drawing of the card?
Yeah.
Yes. If I didn't put that card back, does the probability change?
No.
Yes, so now I have one less card to pick from, so the sample space has now become smaller, right? So those would not be independent events. Okay? So independence. If I had a bag of marbles, and then I had a bag of chips, and I picked out a marble and I picked out a chip, would those be independent of each other? Yes, they don't affect each other. All right, so when we're talking about the probability of independent events, and I would just, if I were taking notes, I would just write this part below the pink line. What we're going to be looking at is now an and probability. We were doing or probabilities in section 4. So now what we're going to be looking at is for the probability of A and B to be occurring. And if those events are independent, which they will be for today, you take the product of the two probabilities. So ors, we add probabilities, ands, we multiply.
So it's like the opposite of what we were just doing.
Right, so now we're going to be taking the products. Okay. If that doesn't work out, then they're not going to be independent events, they would be dependent events. The biggest thing you should be...
Is there some overlap?
The biggest thing you should be getting out of today's lesson is if we have an and they are independent events, we're going to take the product of those two probabilities. Okay? I don't think there's going to be any examples in the homework where they become independent, but don't quote me on that. All right. Yes.
If and independent ones are multiplication and then there's or ones that are, all the or ones are adding?
All the or ones are adding except when they're inclusive and you have to take out that,
Okay.
that overlap. But yeah, the main part, the beginning part is that addition with the subtraction of the overlap. Okay? So get that in your head. Ors add, ands multiply. All right, so 5 examples. If you don't want to write all this stuff down, feel free to not write all this stuff down. We've got 2 different bags. Bag A contains 9 red marbles, 3 green marbles. So if I were taking notes, I'd make a fancy bag. Oops, I'm not writing in pen. There's my fancy bag. I got 9 red, and I've got 3 green. Yeah, it's a sack, right? All right, in bag number 2, we've got 9 black, and we've got 6 orange. I'm going to select 1 marble from each bag. Are they independent?
Yes.
Yes. I want to know what the probability is that I get a green from the first bag and a black from the second one. Well, what's the probability I'm going to get a green from the first? 3 out of...
1/4.
So 3 out of 12, which goes to 1 out of 4. And it is okay to reduce fractions for ands because we're just multiplying fractions. We don't need a common denominator. What's the probability of getting a black?
3/5.
9 out of 15, which goes to 3/5. What are the product of those two fractions? 3 over 20, right? So what would that be as a percent? About 20 times 5 is 100, so 3 times 5 is about 15%, right?
Yeah.
Okay, questions with that one? So far so good? All right, 1 done. Number 2. 2 seniors, 1 from each government class, are to be randomly selected to travel to Washington, D.C. So John is in a class of 18, so let's say class 1 has 18 students. Peter's class, so class 2, has 20 students. Are those independent? If I pick a student from each class?
Yeah.
Yes. If I picked a student from the same class, then they would no longer be independent because once I take a student out, then I have a smaller sample space. Okay, so what's the probability that I pick both John and Peter?
1 out of 360.
How do we get there?
Yeah, me too.
What's the probability that John gets picked out of his class?
1 out of 18.
1 out of 18. What's the probability that Peter gets picked out of his class?
1 out of 20.
1 out of 20. Multiplying them gets 1 out of
360.
360. And then I don't know what that is as percent. Is it 0.3% or something like that?
It's like 0.0002. Yeah,
Point
3%.
oh, so about 0.3%. It's a pretty slim chance, huh? 0.3%. No, that's better than my interest rate on my checking account, so I guess it'd be okay. All right, example number 2, we're okay with that? Yeah? All right, how about this one? Probability of obtaining 3 heads in 3 tosses of a coin.
No.
So I want to know the probability of getting a heads, heads, heads. Now let's think about how we can do this using our and. So I need a head, and I need a head, and I need a head. So that means I'm going to need the probability of 1 head multiplied by the probability of another head multiplied by the probability of another head. What's the probability of getting a heads?
1/2.
So 1/2 times 1/2 times 1/2 becomes 1 out of 8. If you remember that sample space that we did in our practice problems, didn't only have 1 head out of 8 total? So that would make sense, right? 1/8. So that's how we can do it mathematically. Questions with that one? Huh?
What is that as a percent?
What's that as a percent? 1 divide 8. It's about 12.5%. Go with example number 3. Trucking right along?
Yeah.
Okay. Ooh, a good old birthday problem. We love this one. In a class of 20 students, what's the probability that 2 or more of the students have the same birthday?
Oh.
What What would be the complement of this occurrence? Because that would probably be easier to deal with.
18 out of 20.
So if I wanted to know what's the probability that 2 or more of the students have the same birthday, the complement would be,
19 out of
nope.
20.
Now think about this. 2 or more matches. What's less than 2 or more?
1.
If I only have 1, is that a match?
Yeah.
20. No.
One match.
2 or more of the
2 and up.
students have the same birthday.
So
0.
then it's
So it would be 0, right?
Yeah.
So can we find the probability? So we're finding the probability that they have different birthdays. So let's remember how we did this. Let's start with me. How many options do I have out of the year for it to be a birthday, not including leap years? 1, right? Because it's 365 out of 365. Then my birthday gets taken away. So that means that Erica can't have my birthday, so she has how many days to pick from? 364. And we're going to continue doing this how many times?
18.
No, or we're doing 20, right? Because there's 20 students. What would be a way that I could set this up using a combination or a permutation so I don't have to multiply out to 20 spots? First, it's a permutation, very good, because we're decreasing it out. What does 365 times 364 times 363 to the 20th time look like as a permutation? 365p 20, perfect. All over, how many 365s are we going to have in the denominator? 20, so 365 to the 20th power. Get those handy calculators out because that's going to make your life easier. Forget what I got for this. Yeah. So it's about 0.5885. That's what you should be getting on your calculator when you do that. So it's about a 59% chance that we're all going to have different birthdays. So what's the probability that have at least 2 people having the same birthday? All right, so we're going to do 1 minus 0.5885, which is about 41%. I'm going to use squigglies because I'm approximating. Okay, so sometimes it makes it easier to think about the complement than the other way around. Okay, one more. Are we ready for it?
Yeah.
All right, basketball season's coming up. So when you go to take a foul shot, if you make it, what happens? On the first time, you can then take another shot, right?
Yeah.
On a one-on-one foul shot. If you miss the first shot, do you get to take a second shot?
Yes.
No. Not for the 1-and-1 ones, right?
Oh, no.
Oh, you didn't say 1.
So 1-and-1 foul shooting in basketball works as follows. If a player makes the first shot, he takes the second shot. If he misses the first shot, he does not take a second shot. So calculate the probabilities for a player scoring 0, 1, and 2 points in a 1-on-1 foul situation if the player's foul shot average is 55%. Is that good? I don't think that's pretty good. That's a terrible percentage. Okay, so what would be the probability that they get 0 points? So they got fouled, bonus round, they're going up for a 1-and-1 foul shot.
The first one.
Okay, they missed the first one. What's the probability that they're going to miss the first one?
1 and 2.
They have a 55% average of making it.
Oh, I think you need to 50.
Because that would make it not hard to understand.
Yeah, but they can either miss it or make it.
Right, but I have a 55% chance that I am going to make it. So what's the percent that I'm not going to make it?
45.
45%, right? 1 minus 0.55 equals 0.45, so about a 45% chance that I get 0 points when I stand up on the line. What's the probability that I get 1 point? Well, for me to get 1 point, what needs to occur?
That was 55%.
I need to make the first shot,
This is-
and I need to miss the second shot. So that's the same as, I'm going to say hit and miss. Does that make sense to you guys? Hit, miss. So my first shot is a hit, second one is a miss. So what's the probability that I get a hit on the first shot? 55. What's the probability that I miss the second shot?
45.
Calculator it up. What does that get us?
0.2475.
So I have about a 25% chance that I get 1 point on that 1-in-1 foul shot situation. What's the probability that I'm going to get 2 points? Well, what needs to occur for 2 points to happen? I need to have a hit. Oops, equals. I need to do a hit and a hit. So hit and hit. So the probability of one hit is 0.55. The probability of the second hit is 0.55, which gets us,
30.
was it 0.3? So 30%. So what's the most likely event to occur when I stand up on the line?
Make 0.
I'm going to get 0 points for the team. So that does stink. So if I was the other team, I'd be fouling me left and right. So let me step up onto the line. Okay? That's why they do these stats. You don't think they do this in